programs that communicates with other programs across a computer network. Sockets are usually implemented by an API library such as Berkeley sockets. To throw the light on this concept, we have our eminent guest speakers with us. Their conducive environment will make us learn a different experience. Now, I request Ms. Poonam to please come here and welcome our first guest, Mr. M. Tarkeshwar Rao. Right, can we have a round of applause, please? He is currently associated with IBM as a senior software engineer. He had a varied experience of 5 years in the field of telecommunication, C, C++, Unix, etc. Prior to IBM, he was associated with HCL Technologies, Kane Technologies, Cadence Design Systems, CMC Limited. Now I request Mr. Prateek to welcome our second guest, Mr. Kunal Malik. He is currently working as a senior software engineer with IBM. He is an expert in telecommunication, inter-process communication, shell programming, etc. Prior to IBM, he had worked with HCL Technologies, MDOT's Development Center. He is on the payroll of many companies for job recruitment. Now I request our sirs please come on the stage and start the session. And what are the different types of variable? It would be local variable to a function. It may be a global variable. It may be a static. It may be a static variable to a function. So where exactly it got brought into the memory? So we are having a you can say memory model in C where all these variables got stored. We are having a different section that we would be seeing. We know that the scope of the global variable is throughout the application and the scope of a static variable is within the file. So if we are having a static variable as initialized and static variable as uninitialized, where should it go? This should be the question. So we are having the 4 sections in a memory. The first one is the code segment, and above it is a data segment. Then we are having the heap, and then we are having a stack. In the Linux, we are having the address space that we could divide into 2 segments. One is the kernel space, another is the user space. So we divide the user space in text segment, data segment. Data segment we are having the 2 parts. In data segment
we basically store the global and the static variables, and that should be initialized. And in the BSS segment, that itself is a part of our data segment, store the uninitialized values. Then we are having the heap segment and the stack segment. As I said, global variables and the static variables are stored in the data segment. Suppose we are writing printf hello world. What exactly is done once it is compiled? Any idea? After compiling, did you get the executable, or is there any intermediate state in between? After compilation, we didn't get the object file. It's the assembler that gives the object file. We got the machine code, and these are the machine code that itself stored into the data segment. And whenever we are having the C program, there is a different function calls. All these function calls are itself stored into the stack. And in any function, if we are having a memory, that itself goes to the heap. For memory allocation, we use a different library functions like malloc, calloc, and realloc. So these take a chunk of data from the heap. This slide is not clear, although I will try to explain. I started with the bottom text segment. Whenever we are writing any code, starts with a main. So it itself converts into the machine code, and all the data got stored into our text segment. Above that, we are having the global variables in the data segment. We usually store the initialized global section. Thank you. Hello. We usually store the initialized value here. This is the part where the initial values are stored, initialized values are stored. Then we are having the BSS, where our uninitialized values are stored. Now there is a concept of a libraries in C. One is a static library and one is a shared library. Any idea about it? What are the static and shared libraries? Okay. Any idea about the DLLs in Windows? Yeah. Like we are having a DLL in Windows, we are having a shared libraries in Unix. Okay. What exactly happens? Like I divide my project into 3 steps. Front end, where all the buttons and everything all there, and user click on it. Then comes the middleware, where all the events that goes to the threads or process, and then the database, if it is required. So, in our case, if I am using a GUI, say OpenGL, then it would be having some libraries. It may be static, it may be shared. So, if I talk about the static libraries, it is having the notation with a .a. Suppose I am having a package OpenGL, it would be having the library like libopengl.a. So, whenever the compiler compile our code, it itself takes the library into an account and then generates the executable. So, those static libraries are also a part of data text segment. Text segment is also called code segment. There is no difference in between. Now, we are having the static libraries. Now, the question may come into your mind. As in case of a DLL, we may also link those library at the runtime. So we comes up with the concept called the shared library. It is represented by .so. Whenever the program gets loaded into the memory. Loader itself loaded into the memory. It loads all those libraries into the memory, and that itself becomes a part of a heap. Are you getting? Now, all the local variables inside the function, they itself become a part of a stack. So it will come into the stack segment. Data segment and the code segment itself comes into the picture after the compilation. So its size is fixed because we have our global data and the static data. Whenever it got program got compiled, our data segment and code segment is allocated the memory. But in case of a stack or a heap, we are able to get a chunk of memory at the runtime. So these are called the dynamic segments. We can increase or decrease it. So we keep the variables that need to be available throughout the lifetime of a program in the data segment. Global variables are there. Okay. As I said, local variables are stored into the stack. But what about the local variables that are declared inside the function, but they are static? Where it will go? Yes, it's in data segment. Again, initialize the data segment. It will store the variables with having some initialization value. And uninitialized segment we also call the BSS. That is the block starting with symbol. If I talk about the code segment, also known as a text segment, the system may consider this area as a read-only memory area, and any attempt to write it, this area can lead to an undefined behavior. We are having our code, any function, compiler compiles it, converted into .s file, that may be an input to assembler, and those assembled code basically stored into the code segment. As I said, any runtime memory allocation goes into the stack and the heap. So local variables and the function arguments are allocated into the stack, and for the local variables that have having any initialization value, code is generated by the compiler to initialize them explicitly to those values when the stack frames are created. Even if we are not initializing the local variables, the compiler itself generates the code to initialize them. We are having one example. From this example, it would be clear. We are having the BSS1 as a global variable and BSS2 and BSS3. BSS2 is a static and BSS3 is a character pointer that itself is a global. These BSS1, 2 and 3 would be a part of a data segment, and in data segment it would be a part of BSS. Then we are having the global initialized variables like int1, int2 and init3. So these would be a part of a initialized data segment. We would be covering in this, we would be looking at the code after compilation where exactly, we could also see it, where exactly these values get stored. Then we are having our main function. We are having the local variable. It would be a part of a stack, and the code is generated by the compiler to initialize it. This is a local variable but without any initialization value, so it will store